This is a weird place. Swarm, thank you for the tier 1 sub there and for 9 months. David, thank you for the tier 1 sub and for 45 months. Chloe, thank you for the 100 bits. No deck talk. How can you not hear the deck talk? That's weird. One moment, I guess. Why do you not hear the deck talk? You know what? I'm just going to restart OBS on the Office side. That'll probably fix it because I had to restart the audio interface because it was like garbled for some reason. So I will be back in one moment. Lucky Bob, thank you for the 11 months, though. I appreciate that. Okay, I'll be right back. Okay, in theory, we should have deck talk, so let me just try this. So if I restart OBS, it breaks deck talk. If I restart the audio interface, it breaks OBS. It's not too hot. I think it's misconfiguring it or something. I don't know. One moment. Try forcing a sample rate. See what that does. All right, I'm going to shut down OBS. I'm going to turn off the audio interface. I'm going to restart the audio interface, then turn on OBS. And yes, that was my river recording. Yeah. Gotta start both at exactly the same time. Software deck talk time? You know, screw it. Let's do it. There you go. Software deck talk activated. My worst nightmares come true. All right. Hello, everyone. Welcome to the office with the stream where we're going to do work. This is a compromised stream still, though, because for some reason... Did it work? Oh! Does software deck talk not support? How can it not have the Cylon stuff? What do you mean dying? What do you mean nope? How? What? One moment. Hold on. Oh my gosh, my internet sucks for some reason. Why? Why is it not working? Come on!
Tech tangents the API test and set once more. End of line.
Okay, there we go. Blah. Okay. Yeah, I was watching for it on the VU meter for the server. Okay. So annoying. All right. Chloe, thank you for the 100 bits. So, all right, here's the deal.
Tier 100 CI am now working. End of line.
Chloe, thank you for the 100 bits. It's %C. That's why. It's you gotta have the escape character and then the command character. Anyway, but thank you for the 100 bits there. Counter, why is this not working? I actually don't know why it wasn't working. All I did was change the desktop audio source that the server side was monitoring. So, I don't know. So yeah, anyway, okay, here's the deal. We have caps. Cap for the DECWriter 3. We're going to replace all of the capacitors in it. Well, not all of them. I mean, all the electrolytics on the power supply. So, yeah. That's our main goal today. That includes ultra super wonky ones. Look at this. This thing's ridiculous. That is the weirdest capacitor I have ever seen in my life. It is Frankenstein's capacitor with
David
the stud
says, hey,
sticking out of the top.
Welcome to Tech Tangents, the stream where the topics are made up and the channel points don't matter. I'm your host, Shelby Cheer 100. End of line.
David, thank you for the 100 bits. Cute small cap, yeah. It is so much smaller than the originals. It's the same diameter, same mounting spacing, yeah. Now on-screen chat isn't working. I don't believe you. I'm not even gonna look. So yeah, we're putting this one in there, which it's so weird, man. So here's the other thing, though. The chat is working. Okay, good. I set up the cap reforming stuff. We're going to try properly reforming the original capacitors because I want to see what they do. So, yeah. I have needed to get screw-in caps the size of a 1 liter bottle. I hope you did that on the company dime. Jeez. All right. Cheer 100. Yeah, it's that software deck talk. All right. So cap reforming setup is all functional, but I want to see what happens. Can we reform a dead short? I don't think they are, though. That's the thing. But we'll find out. So, all right. Yeah, let's go ahead and do this. So I did just do a reform test of a capacitor there, and it's all up and running and working, which is, you know, always fun because GPIB stuff is kind of a pain in the butt. So yeah. So let's see what happens when we try to properly reform one of these. All right. So we have the positive side here, and we have the negative side there. Now these are 28 volt caps, so let's set up the software for that. Go to setup, target voltage 28, the resistor is 220. We're going to set the current minimum to 1.5 amps and the current milliamps, and the current maximum to 3 milliamps. All right, and then this will be D3 failed cap. All right, here we go. I am really curious to see how these respond. That boom, instantaneous. Yeah, so wow. That's not right. Let's try and put one of the new caps on there and see what that does as a point of reference. So positive, negative. All right. So again, this is a brand new capacitor, okay? Let's run that back. Okay, 28, D3, new cap, okay? Same exact settings. Huh, that's actually taking time. Crazy. You know, have the biggest 1 picofarad cap ever? Yeah, no kidding. Should get some Mountain Dew to refill the empty caps. No, you gotta use pickle juice. Reform the brand new cap to compare. That's what I'm doing right now. Why didn't the PSU work, Mr. Shelby? Yeah, I know, right? So we didn't test this before, and I really wanted to know because it seemed obvious that the old capacitors had failed, but I didn't run them through this test, and this is my benchmark. So that's a new data point that we can catalog. that if the test goes by too quickly, the capacitor can actually be failed. So if we get, it's going to be, it's important to make sure that we measure the capacitance of the capacitor and that it's still within the range. Because if it's not within the range, we could see a result like that. That looked good because it was so fast. It wasn't spending a bunch of time reforming the dielectric. That's because there was literally nothing left to reform the dielectric with. Need to slowly burn in new caps like this. Yeah, you know, I actually am not against the idea of reforming these new capacitors up to this rating because they are pretty big high voltage caps. We have never replaced capacitors this large. So this is actually what you should do. This is the JISC spec thing where you should reform new capacitors that you're putting in there. So we'll run this one up to the 28 volts, and then it's actually not going to take that long. We'll rerun it up to 40 full scale, which actually, you know what? We're not even going to bother. We'll run it up to 35. How about that? Because ideally, this should only be outputting 24 volts on the power supply this goes on to. So 30 would be fine, actually. So we'll do it up to 30. Again on this one, and then we'll do 30 on the other one, which I can go ahead and get out now, and then we should be good. Have they been, oh yeah, they've been sitting on a shelf for who knows how long, yeah. Is this a stream where we finally see Shelby zap himself with a cap? No, because the setup automatically discharges him. Smart. Fingers crossed, excuse me. Lame, yeah. All right, well, while this goes, I'm going to go ahead and sit because it's going to take a little while still. I'm getting the itch to rewrite the entire cap reforming software. Smart or learn the hard way? No, just smart. It's a programmable load power supply. So all I have to do is set the current output to 0 and it will sync. Well, actually, no, I set the voltage to 0 and then it will sync current up to the rating of the current that I set. So, did I bring the Super Nintendo? No, that lives at home. So, for record, up here, you can see the voltage level falling because it is current syncing. 39,000 UF cap on your shelf when charged to 30 volts would create quite the pop if you discharge it quickly. Oh, yeah, I'm sure. So it's on the top connected or just, I do not know. You'd have to look up the data sheet. You can find it on CapsWiki if you want to find that information. How much does a reforming setup cost? I asked for when I win the lottery. 34401A is a multimeter I'm using for this. That you can get for about $300, but you could also get for about $150 one of the 3478As and do basically the exact same thing. I think I have actually reduced the precision of the 34401A to below the 3478A, so you could 100% use the exact same setup there. The programmable power supplies, I don't know how much the 6633A goes for normally. I got it in a group buy, well, not a group buy, a bulk lot. So the cost was more nebulous, but you could probably do the whole setup for $300 to $500 with the high-end test equipment like I'm using here. You could also just get garbage from Amazon and probably do it for $100. I have to reform the caps and some frequency drives every year with 600 volt lab power supplies. Yeah, that's the thing I can't do. I have no means of doing high voltage reforming. Top bowl is isolated from the main cap. Yeah, that makes sense because it's probably just a normal cap that they'd like stick a giant flat stud on top of. So looks like it stopped. Yes. So now I'm going to go back. I'm going to set this to 35 volts and then we'll run it one more time just so that we have some headroom. And then we'll run the same thing on the other capacitor as well. Way more affordable than I thought. Take note. Yeah, no problem. There's nothing special here. It's just how I have programmed my GPIB controllable test gear to work. So this isn't something I bought. I wrote the software that you're looking for the record in case you didn't know that. So I'm just using a multimeter and a power supply. That's it. Black vertical line on the screen near the bottom. So there is. Analog adapter programmable, analog programmable. And a while back, in a GPIB to analog adapter to program it digitally. I have never heard of that. I have no idea what that is. Is it just basically a giant transistor in a rack mount case? The line is just a capture source that doesn't exist. That's it. It's not GPIB, I don't care. That's pretty simple. She'll be by safety stuff in bulk is not the weirdest sentence I could expect there, yeah. GPIB controlled DAC that goes to the reference input of analog supply. Well, that I get, but the analog reference input of a supply is the weird part. It's a very linear curve. It's plotting so far very nicely. Well, it's a brand new cap. It should be. The other one was pretty linear too. Should be tech-changes byline. Yeah. I mean, the USB signalant technically isn't GPIB, but it is also kind of GPIB over USB with SCPI commands. I haven't bothered learning the SCPI commands because it's probably never going to be plugged into a computer, but still. 0 to 10 to map the output range of the supply. Okay, weird. Also, okay, now I actually do want one. That sounds awesome to pair with a signal generator. Because I could just run the output of the signal generator into the power supply to have a beefy power output that's signal generated. Post pick a set of Discord later. Yeah, I'm curious now. I'll control it with a pot. Huh. I mean, yeah, knobs. That's not what we're talking about, though. We're talking about you input a voltage, 0 to 10 volts from what Hellencroft is saying, into terminals, presumably in the rear, and then it scales the output voltage based on that. So if I plug the output of a signal generator into the input on the power supply, I mean, it would be limited bandwidth side, yeah, but still, it would give me a, like, let's say I had a 1,000 hertz sine wave that I wanted to do. It could probably do that, but I couldn't easily, and let's say I wanted 1,000 hertz with a little more oomph than I can get out of my signal generator. I could run that into the power supply and it should totally work. So, yeah, I think that's cool. So we can see the curve there. That is the difference between where we reformed it up to 28 volts and then bam, there's a knee right there. So we are actually doing something by doing this reforming, however you want to think about it. Because yeah, there is 100% a point right here at 28 volts where we last ramped it up, where the angle is slightly more severe. So it 100% did something to do this. Vorpal that is splitting hairs that don't matter. It's just that's being extremely pedantic for no reason. Actually, I didn't fully let that fully discharge. Yeah, still at 12 volts. You want to send 1 kilohertz signal into PSU to get more oomph out of the 1 kilohertz. So,
Hello, Raccoon says
the engineers need people skills.
On the internet, say it isn't so. End of line.
Thank you for the 100 bits. So DZAC, you basically cannot draw any power out of the signal generator. That's what it comes down to. So I forget exactly what the output is. I wouldn't be surprised if it's like 1 watt. So if you wanted to connect, say, a speaker and do a driven test to like maybe characterize the range of a speaker, you can't do it with just the signal generator. You need an amplifier. And you could just use, you know, like a Sanyo amp, but, you know, power supply. All right, we're at 2.5 volts. I'm going to let it go down to sub 1, and then we'll swap in the cap. Yeah, I know, amplifier. I get it. Yeah, I know. I know, but a power supply is also DC. An amplifier is AC, so it depends on your use case. There are legitimate reasons for it. Don't give me that guff. A lot of rechargeable batteries that got over discharged with some sort of similar technique restore them. You know, probably actually, because this is not a battery charger. It does not have any safety, which has pros and cons. But this is effectively exactly how you charge and discharge batteries as well. So yeah, you could. I would make sure you really, really strongly limit the current and probably keep an eye on the temperature of the battery. Actually, Sanity, that's a good point. I wonder if you could, well, those only go up to like 4 volts though. Because I was going to say, maybe you could just use those for reforming caps, but no, it's not going to go high enough voltage because no one has like a 60 volt battery. By reforming, are you depleting and then charging? I am charging and then depleting. So what we do, if you look at the curve here, all right, we start out at 0 volts and we apply a constant current essentially. So the current wavers between 1.5 milliamps and 3 milliamps. That's just listed in microamps here. We are keeping it within that range. When it drops below our minimum, we bump up the voltage using a calculation to determine what voltage level will give us the current that we want. So we're trying to maintain an amount of current going into the capacitor. And then we run that up until we hit our target voltage, which on this test was 35 volts. So I'm just going to go back, new cap 2. I log this data. We can actually replay the logs if we really wanted to, but it doesn't matter that much. So let's go ahead and do the other cap. Voltage depends on the electrode material, which is completely different. Yeah, well, so Resonant Bytes, you just set up whatever voltage and current you want in this software. So you could tune it to whatever you want. So if you're doing a, you know, NiCad that's 1.5 volts, you could just set your max voltage to 1.5 volts, that kind of thing. So starting point to look into at least, yeah. This software you designed, this is my own software, yes. I wrote this from scratch. Well, I mean, I didn't design the JavaScript plotting API or interface, whatever. But yeah, the rest of it for controlling the equipment and everything and the concept is mine. I actually want to rewrite it. Not just on the HP Series 200, which I do want to rewrite it on there, but I think we can do better now. I would like to take some of my modern design ethos of how I write Flask Python software and apply it to this, because this is single-threaded, which sucks. It also has the UI as a core dependency. I cannot, if I don't have the console that I run this in a big enough size, it will crash because it can't draw the curses UI. So I would like to rewrite this because it has some problems, but it's still really helpful. The step nature, intentional is an artifact of how you do this. Do this much quicker. PID loop, dedicated device, keep its current exactly stable. So it's an adaptation from the traditional means of doing this, which is to take an analog power supply like that one over there, and then slowly bump the voltage up until you reach the current level you want, and then wait for the needle to drop down. I could do a constant current, program the power supply for that. It's a little more complicated because we are running the power supply below current levels that it can actually control. So this power supply has a minimum current step of 0.5 milliamps. We are drawing 1.5 milliamps here or something like that. So that is 3 steps of control that this power supply can do. So trying to run in current controlled or constant current mode is really hard with this. So using the voltage gives us a different scale to change with the current limiting resistor we have in there, to more precisely control what voltage or what current we are outputting. Doing this also allows us to have current steps or current limits that are below what the power supply can output. I do know, Sanity. There is no suitable hardware, Vorpal Sword. If you can find me a constant current power supply that goes to 50 volts and has, let's say, 10 microamps precision, let me know. What's the minimum resolution of the ammeter? Insane. It's so precise that I did build one right here. It's so precise that I have intentionally reduced the resolution to make it faster. Did I get better internet recently? Notice the stream is more clear and stable? No, it probably is just because I'm not moving the camera around a lot. It's called a high voltage op amp, basically. Yeah, but that's going to introduce noise. And probably noise on the level that we're trying to work with. Measurement is great, control is not. Controlling voltage works fine, yeah. Question was to make it regular battery charger. Misunderstood the assignment. Okay. You want constant current reference standard. They are low current and high voltage. Is it adjustable voltage though? I mean, I guess it doesn't have to be adjusted, but something's got to adjust at some point. That's actually something else that I want to, didn't you bump up the bitrate a little bit, but it's not that insane. I can tell you what it is. I would like to have a gradient for the current. So the current output bit rate is 2.5 megabits per second. Anyway, I would like to have a lower and an upper bit rate, or not bit rate, current rating, because on capacitors that are really bad, when you get into like 75% of the total voltage rating that they're capable of doing, you might have dielectric that is significantly degraded if it hasn't been used in a while, and it can take forever to get it to actually reform. So having 2 current maximums would actually be beneficial. So pictures 2 units on Discord. All right, I think it was linear until about 8 volts. I have no idea what you're talking about. Okay. Yeah, that looks really good. Man, those caps are horrible, the old ones. Wow. For giggles, you want to try and throw one of the other caps on there? So this is the 6.3 volt cap. This goes on the 5 volt rail. And this one should also be absolutely roasted. So for giggles, let's go to setup. We're resetting everything. We're only going to run this to 5 volts. We'll set our current maximum to 500 milliamps, or our current minimum to 500 and our maximum to 1 milliamp. D3 5 volt cap. Start. I'm suspecting that went a little too fast. What did I set the target? Yeah, target
at tier 1.
5.
They've subscribed for 43 months. And says another one. End of line.
Spooky, thank you for the tier 1 sub there and for 43 months. I appreciate that. Open one up, see if it's empty. I don't really want to because they're a huge mess. Yeah, 500 microamps. Yeah, that is microamps, yes. It's 0.5 milliamps, 1 milliamp. You know, it's really hard to run such low voltages through this because of the way it steps. So we could reduce this even more, 50, 100. That'll probably... Nope. Really? Why? Huh. Yeah, it doesn't matter. This cap's probably also completely roasted. All right. Well, that satisfied my curiosity to see what the other caps looked like and how horrible they are. Great. There are no reference designators on this PCB. We need to make a map. Give me 1 second here. I forgot. Maybe there's an image in the manual that shows it. 1 second. I know you can't see anything I'm doing over here. I just want to make sure. I think I downloaded the manual for this, and I think it's got a weird name. Starts with an M. Yeah. Okay, let's look at this for a second, see if we can figure out where each part is. Annotate a photo. We'll see. I can't remember because we have some schematics and stuff. So this and this. Okay. All right. So this is the schematic for the power supply. This is what we're going to be replacing parts from. So we are replacing C7 for sure. I mean, we're going to replace every electrolytic at this point because the thing was left on for probably decades. Excuse me. I just can't remember if the board layout here, it does have stuff. Okay, perfect. So I don't need to create a cross-reference. It's not a stupid schematic. I forget what other thing we were looking at that didn't have everything on it. It was so annoying. Let's see. Orientation, rotate, right. Beautiful. Okay, so we'll just go ahead and leave this up over here, and then I'll pop back to this when I need to reference it. I think that'll do. Yeah, okay. So that's everything that we need. All right. Head solenoid driver board didn't have parts cross-reference. Ah, yes, that was it. So it was still DEC. I thought it was data general for some reason. All right. I am now recording. This goes up to 100 volts max and nanoamp resolution. I'm going to guess $3,000. Oh, it's only $895. I mean, I like the other HP thing. No. Yeah, that current source seems familiar to me. That's interesting. That could be useful. What is that piece of equipment under it, though? That's not some, like, ultra ridiculous pico amp meter DC voltage source on the bottom? What? That's weird. I don't understand the purpose of that. So, yeah, I think EEV Blog does have one. It looked familiar. Okay. Anyway, what I was going to say, I am recording this to try and make a video out of it now because oops, hold on, I accidentally turned on the second mic. The whole process of diagnosing the capacitors and the portable oscilloscope I found to be kind of interesting, so I want to make an actual video out of this. So, gonna be doing some recording, just heads up. Alright, let me get the stabbing implement out of here. I don't know why we have a AA over here. Oh, we probably measured that with the Sigilant as a multimeter source. I guess I'm going to need the solder in a second. I won't put it that far away. Okay. I will... I'll warn you in advance. I did not perfectly spec all the caps for the footprints. I kind of guessed on some. So, we'll see how this goes. This will be the ultimate cap reforming supply, but it's not programmable. Although it doesn't really need to be if it can be set to like super low current and then just roll. So, okay, I'm going to put these gloves on that cadmium tray down there. Is that it? I think that's it. Footprint should be close enough. I measured them by knowing what a couple of them were and then looking at this image and using relative measurements in like GIMP. So it's really like not amazing, but it'll probably be fine. There were some that I was never going to be able to match correctly anyway with the three-legged ones. Those were super dumb. Like this. I'm not going to try and match that. That just isn't happening. So this one I probably got way wrong. All right, let me get this out of here so this doesn't look weird on camera. Just get under the table. No one needs to know there's things down there. Okay. Has a reference input so you can control the GPIB DAC. I hear you trying to whisper like into my ear to buy it. Ain't happening. All right. Here we go. Let's get started. Well, I will say that was enlightening to see the reforming of the caps that went here. They were definitely extremely bad. And I reformed these as well. You know what? We should intro that a different way. I should say that I'm reforming these. You know what? I'll do this as the narration for the reforming, actually. That's what I'll do. All right. Now, before I recap this with the new giant caps, I have gone ahead and attempted to reform the original caps. Did I call it reforming? You know what? I am off my game right now. All right. One more time. All right, I have all of the capacitors here and ready to go, and before I put these on, I went ahead and tried reforming the original caps with my giant cap reforming setup, and that was definitely enlightening that these are terrible now. So they reformed almost instantly. The way that chart went with it being so fast tells me that there is basically zero electrolyte left in these. I'm not going to open them up. That's just going to be a giant mess and kind of a pain in the butt, but I bet there is almost nothing in here, that they're totally dry. And as a demonstration of that, I went ahead and reformed these as well, because these are also pretty high capacity and high voltage caps. It's actually the kind of thing you would be recommended to do if you read the data sheet for these. So reforming those was a good idea, but they took way longer, basically infinitely longer compared to this. This only took as long as it took for the meter system to decide, yeah, we've actually reached that point, but it was just getting there like one after another so fast. So yeah, these totally dead. And it's probably the same with all the other caps in here. So we're going to wholesale replace everything except for these, because those were totally fine. I did measure them before. But yeah, these little ones down here, all getting swapped out. There we go. Now we said words good to camera. That's the best you can hope for. Okay, minor thing here. I don't remember why there's so many caps in this bag. I swear that there's only like 3 things that we're replacing, but maybe not. So, okay, we got 18 and 21. Those are at the top. So these are the replacements for these axials. Okay. Then we got just C15. There's one. We need one of these. Okay. C15 is the one that I removed. So that's one of the 3-legged ones. So we only need one of those. And then I guess...
End of line.
I guess it's just a lot of volume. The consolist, thank you for the 100 bits, sir. I appreciate that. And hello. Your rules, 10 are enough to fill a price? Yeah. Oh, you should see some of the crazy stuff that I got over here. I have not yet put these away, so you can see, like, here is Data General Walkabout. I needed 2, so I bought 50. Like, just because they're basically free. It's ridiculous. Me streamer, me words good, yeah. Did you order for the Game Gear as well? Yeah. Did order 10 of each, right? I mean, I did not order 10 of these. But yeah, I ordered a lot, I guess. Yeah, I have the Data General one off to the side, the Walkabout, so that I can put the extras away. Axials, not cheap though. So, all right, so this is gonna be C8, probably that one. It is, that makes sense. And then the axials are the only axials. So yeah, that makes sense. These are technically smaller, but it's not like it matters. All right. Let's get started. I guess I can use the desoldering iron because somebody accidentally left the air compressor on for the whole 2 weeks they weren't here. Oh gosh. So it's charged. Be cool when OLED screen mods start being a thing. Pretty sure it already is. At the very least, Paul Guy, the IPS displays that you can get, they're good enough. Seriously, you don't need OLED. Just get yourself a modern IPS display. They're fantastic. The air has to be almost solid by now, yeah. Oh, I didn't leave it charged. I left it on, so it kept like slowly leaking out and then recharging. Ugh. I did not intend to do that. We're waiting for the desoldering iron to heat up right now. Oh, it's got a ground fault. Hold on, stupid. That cow. Your new oscilloscope, bad DMM charged? Yes, because I recorded a video about it yesterday. And I charged it beforehand to make sure that it would be good. You'll be listening while driving? Focus more on driving than listening, though, Jason. 39 UF 16-volt caps is a 10mm socket of capacitors. All right, this is heating up now. Where's my stool? Duck Talk voice for Satnav next. You know, it almost makes sense that they would just rip it off to do that with, but now everyone's got to have that AI voice. It sounds real. Nerds. This thing takes a while to heat up. Yep, still not there. Portizo, it's funny. I really enjoy how the Deck Talk sounds and works. I think it is incredibly advanced. I don't think the Deck Talk gets enough credit for how good it is. Ever wake up hoping today's the day the bubble bursts? Yeah, no kidding. Dude, I cannot believe Crucial is gonna be gone because of it. This is just insane. Deck Talk is peak TTS? It really is. Peak in 1984. It's just crazy. It's getting close. No, it's not. I'm an idiot. I heated up the iron. Oh my gosh. Do I feel stupid? Okay. I was like, wait a minute, it's not getting close. It just bent when I put it in there. Yeah, I will say, Sanity, perhaps the voice dialect, phoneme should have been based on a native English language speaker, but, win some, you lose some. Okay, now we're stuck waiting for the thing to heat up again. I'm so glad I'm recording this. One thing I've learned, don't stop and start recording with the ATEM a whole bunch because it has very annoying sync issues between all of the sources, so just let it ride. Sync it once, don't think about it. Perfect, Paul, yeah. Also, this is really annoying, okay? It's a complete sidebar, all right? For some reason, OBS on my desktop records slightly slower, I want to say, than my phone at home. So when I try to record multicam or audio with the desk mic, it desyncs. It's super annoying. And I swear it's like the difference between 59.94 and 60 frames per second. But OBS is set to 60 frames per second and the phone is set to 60 frames per second. So I think possibly the phone is lying and it's not correct. I don't know. It's so annoying. Crucial just stopped their first party brand making the same number of chips. It's not really going to change anything. Yeah, it is. Because they're not selling to consumers. I'm not going to be able to buy Crucial memory. Yeah, but 44.1 versus 48 is a much bigger difference. I think we're talking it drifts noticeably after like a half an hour, maybe 20 minutes at most. It's really small. I'm pretty sure OBS is 48 though, because I have it set to be the same as the ATEM, which is 48. Okay, how about now? You ready yet? Dude, what? How? Okay, it's definitely getting warm now, but it's not yet. You have to scroll through and look at which frame jumped. I'll eventually put the effort into figuring it out, but not right now. I mean, we're not home right now, for one, so, you know. Was anyone buying Crucial RAM anyway? Yes. Lucky Bob, but Founders Edition cards do not make up a significant portion of the market for consumers, whereas Crucial was massive. They were a huge player in the consumer market. OSD for desoldering iron temperature next. I would actually be okay with that. Maybe not an OSD, maybe just some kind of current draw rating to tell when it reaches steady state would be good enough. There we go. All right. Let's start yanking caps. Oh, that's cool. I don't know how I missed that first time. The extremely standard and totally normal positive marked capacitors. Yeah, that is exactly what everyone expects to see when they're working with capacitors. Mm-hmm. All right, so these are the 560 microfarad 20 volt caps, and these are 680 microfarad 25 volt caps. So these are good enough. I kind of rounded values a little bit this time, trying to make the most sense with some things. How do axial caps work with that kind of marking anyway? It points to which end of the capacitor, because the stripes are an arrow. Does your 3D printer setup look like at the moment? It looks like that. It's not powered and I can't turn it on because the whole wall over there and going up. Power's back. Okay, that means construction's probably going to start again. Fun. Anyway, I was going to say the wall had lost power. But yeah, it's just a Tron XY 3D printer. I want to replace it with a Core XY at some point. The Tron XY is a brand. It's not a Core XY printer. It's just lying. Core XY. Oh, that's right. These suck. Oh. I forgot how much I hate this stupid deck soldering. Great. Oh, they can have them, DZX. That doesn't mean I want to pay for them. Not going to go drop $500 on a 3D printer. Ugh. Let the fun begin. Are quoted messages picked up by the vote? I don't know what you mean by quoted. It's exact string when it's a poll that shows up on screen. Okay. So I need to remove the axial caps here, but every single part on this circuit board has the legs folded over, so this is going to be a pain in the butt. You can see them right there. I need to get these out of here, which is going to require flooding and then removing the solder so that stupid thing will work. I love how their legs bent over on a copper plane as well. Because, you know, if you're going to make it hard, you might as well make it really hard. I don't... Did they ever try to sponsor a printer? I have never talked to a 3D printer manufacturer about doing sponsored stuff. And I have not heard back from Keysight. I think I should email them from not my custom domain email. That might have gotten blocked. I don't know. This be Majenko or Ben stream? I mean, they do deck stuff, and this is a deck board, so that would make sense. There we go. All right, leg 2. Like it's a job for solder wick. Solder wick is not going to get underneath. There is no job for solder wick. Solder wick sucks. Ooh, solder wick. Am I using low melt there? I'm using leaded. I'm not going to waste chip quick on this, if that's what you're getting at. Oh, that worked great. Could be data general boards, even large plain copper would fall off the moment you touch it. Yeah, no kidding. In the end, just get a good Prusa. I mean, it's all expensive. I don't use a 3D printer enough to justify spending a lot of money on it. That's what it comes down to. Just gonna try and clean these up one more time here. I'm not sure what's going on. They might just be bent. I'm about to have to turn on my air compressor. Yeah, DZAC, I think you know that's not gonna happen. Come on. Here, DZAC, my turn. I'm going to DM you during a stream, and then you'll get it. When I promote Weird Al streams with my money, I will promote Weird Al for free. Weird Al is awesome. What are you talking about? Come on. Oh my gosh, this one does not want to let go. All right, before I get these fully released, if that'll ever happen, let me take some pictures of the orientations. this kind of sucks. That's hard to tell. Brought to you by Capacitor Reforming Polka. Yeah. It's yours his last tour. It's his last one? Did he say that? I didn't know that. What are the black axials? Resistors or inductors? They're resistors. Okay, both legs are loose here. I should be able to pull it out. Come on, man. Yeah, now you get it, DECWriter? Lots of power being just not a very efficient PC. I mean, it's from the 70s. Oh my gosh, come on. Well, I pulled that leg out. I'm afraid I'm going to rip the other one out of the bottom of the capacitor here. Oh. They're three-legged. This is one side. That's the other axial that went over top. That's the other side. Deck. Why you gotta pick the weirdest caps ever? So they're like this. This is another capacitor that I removed from this thing that was bad. They take that cap. You deserve to live on the floor. They look like an axial from the top, all right? But they're actually radial. And then the third leg is for stability. You're meant to mount these as if they were an axial, but then have them just be a radial. So I assumed these were just more normal axial caps, but no, they're the weirdo radials. So yeah, I need to desolder that one as well. So there's no way you can see that from above. You just have to know. Because again, they just look like regular axials elsewise. There's no way you could know without being able to identify them in advance. Or like for stability. Apparently they're for like aircraft or something. Okay, well now the polarity like extra matters. I am negative marking these stupid things. Okay, so positive is the one that I removed last. So this is negative. And then on this one, positive is assuming opposite side. Yeah, so that's negative. All right. Have you missed anything fun? Only more stupid three-legged capacitors. Also, we reformed the original big caps. They're super, totally, ultra dead. Tripacitors, yeah. I don't like how that went. I feel like I'm not getting any vacuum. Ow, the things get hot when you put them in the hot thing. There we go. All right, that's one of these stupid capacitors out. Now we have one more to go. Although I will go ahead and just put the new one in now while the markings are still visible. So negative side mark, like a capacitor should be. And then that's actually backwards. Okay, it should be negative to the edge of the board, and it is. Okay. Shh, don't look. This is how you're supposed to solder. Okay, let me get some snips. Okay, we are an hour and 16 minutes in, and we have one capacitor replaced. So fun. All right, let's get the other one out. So we have this grouping of 3 pins that we need to remove. Of course, they're all folded over. think that one got everything that was under it. Okay, vacuum has been lost again. Maybe I should open it and check. I mean, there's only a ton of stuff all over in there. I can't see why I would lose vacuum. Look, spin, send it. Yeah, exactly. Okay, I think I gotta actually resolve that. I think it might finally be time to replace the filters. Normally I just clean them and move on, but I think I actually need to replace them this time. Okay, where are they at? Not up here, are they? No, I think some idiot put them away. Why do I have a tiny little OLED down in this drawer getting ready to be cracked? That should not be there. You don't want to put that in a drawer back here. So that desoldering iron, if you have been only loosely paying attention, has two filters in it. One is like a solder diaper that catches all the giant blobs of solder, and the other one is a fume filter. Fume filter looked pretty clogged up, and the solder diaper was super clogged up. Normally I just empty the solder diaper and I will keep on trucking, but I think both are fully used up this time. So I think I actually need to swap them out, but I don't remember where I put my spares. So I need a moment to find them. In theory, I could run it without them, but that would be a super bad idea. Where did they go? How long have those filters been on? I don't know, like a year or two. Maybe closer to a year. It's not really time as much as it is use. I don't always use the desoldering iron, but I have been using it more. I replaced the filters once when I got it. I have not replaced them again after. Where did they end up? Okay, we might have to just try and clean them. And then next time I see them, I'll keep in mind that they need replaced. So I don't want to spend all day on this. think that's what it's going to have to be. That's unfortunate. I would really like to know where they went. All right. I'm going to turn it off. What's the problem with tidying up? I know, right? Okay. So cleaning out all of this stuff is going to be fun. Let's glove up for this. This is a very high concentration of lead dust. Well, in this case, Paul Guy, I definitely organized them away somewhere because I was trying to get the work surface completely clear. And then I didn't think about where it ended up. All right, so that's going to be good enough for now. It's just a little bit of lead dust. It's fine. Yeah. Yeah, these definitely don't need to be replaced every time you clean them, but this one's past prime. So this filter, wow. The dark line on the exposed part of that's crazy. So we'll just flip that around for now. That's insane. All right, that'll be good. Let me let it heat up again. You know, there's some circuit boards that are just always a nightmare to work on, and this one definitely falls into that now. I will never want to work on DEC stuff. Everything, its cot gets blown off the dirty side and into the office. Phil, no, it captures the stuff, like the flux that you would get. It pulls that into that filter. That's what that black line was. That was the flux residue. Now we just wait for it to heat back up. It's probably not far off because it wasn't off for long. As long as it actually turned on. It did. Black line now faces outward though. So actually no. It pulls down from the center. It doesn't blow through. So it goes in and then makes a 90-degree angle through the filter. So I put it on the back side so there's no air pressure going that way. So I've been rotating the filter to use the different sides because there's a Venturi valve in the handle that this goes along and then it ejects all of the air down here. So no, it's not pulling all of the stuff out of the filter now. There we go. Was concerned? Don't worry. It's fine. Oh, yeah, that's the stuff. That's way better. Wow, that has so much more oomph. That's crazy. Where's the edge? There it is. I have learned that the desoldering iron is the least likely way to damage the circuit board. So that's why I prefer it. Solder sucker, it's really easy to slip up and punch the circuit board with it and cause a lot of damage. Solder wick sucks. There's no way around it. I don't understand why people like it so much. It's awful. Ow! There we go. I think I need to put a little more solder on there and then pull it. And boom. Ugh. Stupid capacitors. All right. Positive and negative. There we go. Boom, boom. And there we are. Wah! Okay. Hello, David Ebsey. Let's catch it up here. Ugh. All right, so that's our first value of capacitors down. It goes into stock now. Just 4 more. One more of them is a 3-legged one, so let's just go ahead and rip that Band-Aid off right now. It is this one. So we got lots of crinkle traces and, yep, folded over legs. Thankfully, this one's not on a ground plane this time, so this shouldn't be as bad, but it's still not going to be tremendously fun. So we're going this, and the positive side is this one. So I'm going to do the thing again I don't like, and I'm going to mark this. This time I basically have to mark the solder mask, so we're going negative there. Yeah, you got it right, Philip. Oh, you guys are talking about sugar juice. Got it. I'm out. All right. Ooh, that one went well. That one too. But they're not free, so we're still not done. And this one, these are like, oh my gosh, these legs are so thick. They're going to be ridiculously hard to bend too. So yeah, this one sucks. This one's bad. Which desoldering iron is that? It is a Metcal DS1. So it takes an air compressor into this part, and then this connects to the Metcal MX500 base station. Oh gosh, how am I gonna do this? So bad. So those of you espousing Solderwick, how would you get Solderwick to do better than this on this application? Not saying that I'm going to use it. I'm just saying that this is not going to be solved by Solderwick. This sucks. This is just bad. You wouldn't, but it's better than nothing. That I will agree with. Maybe. Flux. I mean, that's still not going to get... It's not going to solve everything. I could put flux on this. There we go. Fluxy, fluxy, flux. Flux, flux, flux. This is not about how to remove the solder. This is just about how stupid bending the legs over is. MX5. Oh, I mean, well, yes, obviously. I have seen your uses of flux. I mean, yeah. Desoldering pump comes with low risk of damaging the boards, capable of giving you the black eye if you aren't. Yeah, see, that's. The Soldapult is the best one of that I have encountered so far. It works pretty well. I do prefer this by far. But yeah, it's not cheap. I managed to get this gun as an incomplete part, so it was less expensive because I already had the base station. Because I've been infected with Metcalitis for a while. Yeah, Lucky Bob, that's basically what I'm trying to do. It's just a pain in the butt. They're really folded over. They're totally flush. Like, I actually don't know how they got them quite so flush. Because the hacking, not great. It's really slow because of the stupid bent over legs. All right, I'm going to try the iron. And then just flood it and bend it. Especially with these, I'm really concerned about just ripping the pad off. Gosh, I swear it's like they soldered it and then put the solder mask on. This blade's not going back in the box cutter. I need this to cool down a little bit. Ball peen. Hammer? Like, small toffee hammer and putting it together? Oh. It's like, how am I using a hammer to remove this? Flush cutters to grab the end. But, ooh, you know, actually, I kind of like that. Let's try that. I'm going to destroy these flush cutters doing this. Okay, that one's upright. Upright. This one's just a mess. There we go. That's into the domain of the desoldering iron now. Tool abuse, yeah, no kidding. Did I get any solder stuck to these? Thankfully not. Knife though, yeah, both ends. Calling all poker haters being all hurt, yeah. Okay, we're probably gonna lose stream at some point. Okay, I can't see chat right now. I'm just gonna kind of hope that you can see me. Actually, I wonder if I can do this. One moment. Okay, that might be working. Yeah, can you guys see me right now? Like, hello? Can you see me? We can see you. Okay, yeah. So I'm on my phone. Here's what's gonna happen. I'm gonna stop stream. There's construction going on, and they're playing with the breakers. And that's gonna be not conducive to streaming. So, yeah. I suspect since the breaker was off when I came in here, they're going to keep needing to do it, especially because I think they are probably installing solar panels. So I don't think that I'm going to be able to work around that. Hopefully they don't work Sundays. Yeah. So I suppose we'll continue this tomorrow. But yeah, I think I'm going to have to stop for now. This is very frustrating. But yeah, I don't want to keep stopping and starting this. So yeah, and then the stream PC. Yeah, grub no happy because it doesn't. Computers don't like getting shut off random. So yeah, timing sucks apparently. Yes. All right. Well, at least make that not as horrible to look at. Yeah, hopefully tomorrow's better. Yep. I mean, I tried to stream at the office. I mean, I did. Okay, well, sorry about that. All right, here's what I'm gonna do. I'm gonna wrap this up here. All right, and then I'm gonna have to remote in my server from my phone, and then I'm going to yeah. Oh my gosh. Okay, you know what? Before, do we just? Oh my gosh. Maybe look at the Dreamcast. Yeah, you know what? Actually, do we just want to try for a home stream tomorrow? Just the guaranteed stream, because I don't know when this is going to end. So yeah, we could do a home stream. We could look at the Dreamcast. So here's what we can do. Tomorrow we can do basically this capacitor replacement, but we're going to do it on ask them. They're on the roof. I hear them. So tomorrow, here's what we'll do. Tomorrow, we're going to recap 2 Dreamcast power supplies, and we're going to test a bunch of Dreamcast GROMs. How about that? They did not inform me beforehand. No. That it could happen. Nope. I had no advance notice. So, yep. Yeah. And this is not the first time. So, might be off considering it's Sunday. Yeah, you'd think that about Saturday too. So, your tenant, ask them. Here's the thing. I am very sure they are installing solar panels. So, they're going to need power to be off and on. I'm not surprised. I don't know. Here's the thing. They're definitely going to be doing it today. So I'll see if I can ask them on my way out. And then I will make the determination after tomorrow. Or for tomorrow after. Alright? So I'm going to wrap this up. I'm sorry for the spontaneous ending here. And yeah, let's turn on your pressure right now. There we go. Yeah, sorry about the spontaneous ending. But we'll see what happens tomorrow. So yeah, all right. Usual if you enjoyed the stream, follow, but it's like this is a frustrating ending. Yep. But all right. I'll see you all later. I gotta yeah, this is... Yeah. All right. Thank you for at least trying to watch a stream day. I appreciate it. So I'll see you all next time. Bye.